Section 3.6, Factor Completely. In this section, we will use factoring concepts that were covered in previous sections to completely factor a given polynomial. When factoring a polynomial completely, ask yourself the following questions about the polynomial. 1. Is there a greatest common factor? If so, factor out the common factor. If the leading term is negative, factor out the negative GCF. Is the polynomial a difference of two squares? If so, factor. Is the polynomial a perfect square trinomial? If so, factor. Is the polynomial a trinomial that is the product of two binomials? If so, factor by trial and error. Does the polynomial contain four terms? If so, factor by grouping. Factor completely. Alright, so notice in A we have a trinomial. So the first thing I'm going to do is, well, I'm looking at it and I notice it is in descending order. I'm going to look for a greatest common factor. I notice that only the first two terms have a b, so I can't factor out a b, but I do notice that 15, 115, and 70, it looks like I can factor out a greatest common factor of 5, so that's what I will go ahead and do. So I'm going to factor out a GCF of 5, and then I will divide each of these by 5. 15b squared divided by 5 is 3b squared, minus 115b divided by 5 is 23b, plus 70 divided by 5 is 14. And so now I will go ahead and try to factor the trinomial, and I guess I will go ahead and do that by trial and error. I'll just drop down the 5 factor. And then recall that this is your F, this is your L, this is your O and your I. I recognize that this is positive. So down here, when you factor your two binomials, you'll have to have the same signs. So my F here and here are factors of 3. So my only choices are 1 and 3. So 3b times 1b. And then for my L, I have factors of 14. My choices are 1 and 14 and 2 and 7. And I'm going to try to put these in the right spots. I believe that my 2 will go with the 3. And my 7 will go here. 2 times 7 is 14. And now I will check my inner and my outer to make sure it adds up to negative 23b. 2 times b is 2b. 3b times 7 is 21b. And my signs both have to be the same. In order for it to add up to negative 23b, they would both have to be negative. So my answer is 5 multiplied by 3b minus 2 multiplied by b minus 7. Or you could have the b minus 7 in front of the 3b minus 2, but I would put the 5 out front. If you put the 5 behind, you'd probably want to put it inside parentheses, but it's best to put the GCF out front. Alright, let's look at b. Alright, so we'll look for a GCF. It looks like we can factor out of there a 3x. When I factor out a 3x, I'm left with x squared minus 12x plus 27. And now I will factor my trinomial. I notice this is positive, so my signs will be the same. I'll circle it so it doesn't look like I put a negative behind there. X times x is x squared. I have factors of 27. My choices are 1 and 27. And 3 and 9. I want the two that will add up to 12, so 3 and 9. 3 times x is 3x. X times 9 is 9x. I need it to add up to negative 12x. So they would both need to be negative. So I get 3x multiplied by x minus 3 multiplied by x minus 9. All right, for C, we have 45a squared plus a squared b squared minus 14a squared b. So let's see, not all terms have a b, but notice each of the terms have an a squared, so we can factor out of there an a squared. Let's go ahead and do that. And when I do that, I kind of wish, let me get me an eraser. I want felt tip pen. Okay, so I factored out an a squared, so I'm going to be left with 45 plus b squared minus 14b. So now I want to rewrite that in descending order before I factor it. So I'm going to have a squared, and then I'm going to rewrite it as b squared minus 14b plus 45 in descending order. So now I will go ahead and try to factor that trinomial. So looking at my f, I see b times b is b squared. This is positive, so my signs will be the same. For my L, I need factors of 45. So 1 and 45, 5 and 9. I'm looking for the two that will add up to negative 14b. So 5 and 9. 5 times b is 5b, and b times 9 is 9b. We're looking for negative 14b, so they would both have to be negative. And I'm not going to rewrite that again because I don't have any room at the bottom, so this is your answer right here. A squared multiplied by b minus 5 multiplied by b minus 9. All right, now notice the next trinomial. Since my leading term is negative, I'm going to factor out that negative. So the GCF of 5, 15, and 10 is 5. And I can also pull, we have an x cubed, an x squared, and an x. So the GCF there is an x. So I'm going to factor out a negative 5x. Negative 5x. And when I do that, I will be left with an x squared minus 3xy plus 2y squared. So I'm going to drop down my negative 5x, and now I will try to factor that trinomial. X times x is x squared. For my L, factors of 2 are 1 and 2, so I get a 2y multiplied by 1y. My signs will be the same because that's positive. So 2y times x is 2xy. X times 1y is 1xy. And it needs to add up to negative 3xy, which it will as long as they are both negative. So I will write my answer as negative 5x multiplied by x minus 2y multiplied by x minus y. Take that coefficient 1 off, even though I put it in there to begin with. All right, let's do a few more. E, we have 32xy squared minus 48xy plus 18x. And we're looking for the greatest common factor of 32, 48, and 18. It looks like the biggest number that we can get into there, I believe, is a 2. And we can also factor an x out, but not a y, because the 18x doesn't have a y, so we'll factor out a 2x. And when I factor out a 2x, I am left with 16y squared minus 24y plus 9. So I have a trinomial to factor. Now you may want to notice, look at your first and third terms. The 16y squared and the 9, those are perfect squares. So this very well may be a perfect square trinomial. So let's treat it as such. You see that 4y multiplied by 4y is 16y squared, and 3 multiplied by 3 is 9. So let's just check our inner and our outer. 3 times 4y is 12y, nice, and 4y times 3 is 12y. Notice we're getting 2 of those. It needs to add up to negative 24y. Great, as long as they're both negative. So let's rewrite our answer as 2x multiplied by 4y minus 3 raised to the second. Notice that in f it has 4 terms, so we will be factoring by grouping in f. So we will group 4x minus 20 and factor the GCF out of there, which is a 4. That will give me an x minus 5. Now notice the negative x cubed and the positive 5x squared. When I factor this side right here, I want to have an x minus 5 as well, right? When you're factoring by grouping. Which means you want to factor a negative. When you factor something out of here, you want it to become positive, and when you factor something from the 5x squared, you want it to become negative. So we want to factor a negative out. So it looks like we will be factoring a negative x squared out. Because a negative x cubed divided by a negative x squared will give me a positive x, and a 5x squared divided by a negative x squared will give me a negative 5. So now we have 4 times x minus 5 and minus x squared times x minus 5. Now I can pull out the x minus 5, and when I pull that out, so I'm dividing here because I'm pulling it out, I'm undoing that distributive property, I am left with 4 minus x squared. Now I'm not quite done here, because if you look at 4 minus x squared, you'll recognize that that's a difference of squares. So I can't do anything else with the x minus 5. However, 4 minus x squared I can factor again. 2 multiplied by 2 is 4. X multiplied by x is x squared. And recall that when you have a difference of squares, when you factor that, one will be a positive and one will be a negative. So we get x minus 5 multiplied by 2 plus x multiplied by 2 minus x. That will be your final answer. That was a fun one. Alright, for g we have 8n squared minus 72. Let's factor out a GCF of 8. When I factor out an 8, I am left with n squared minus 9. N squared minus 9 is also a difference of squares. N multiplied by n is n squared. 3 multiplied by 3 is 9. One is positive and one is negative. And recall that if you check your inner and outer, it adds up to 0. That's why there's no middle term. That's why you have a difference of squares. So you get 8 multiplied by n plus 3 multiplied by n minus 3. H is also a difference of squares. Y to the 8th minus 16. That will factor to y to the 8th, y to the 4th times y to the 4th. 16 is 4 times 4. One is positive, one is negative. You cannot factor y to the 4th plus 4. However, you can y to the 4th minus 4 is a difference of squares. So that will factor y squared, and we'll have a plus 2 and a minus 2. So we get y to the 4th plus 4 multiplied by y squared plus 2 multiplied by y squared minus 2. And that takes us to our U-tries. So I will go ahead and stop there.